Okay guys, in this video what I want to do is I want to go over number 4 from the logic project worksheet. I believe this was in worksheet 3 or 4. It's one of the ones that we worked on today. I myself got a little bit tripped up on it when I was going over it with you guys. So I wanted to make sure to make a clarification so that we are in agreement as to what the answer to these questions are. So let's go over, this is number 4. If P represents Brian Daly intended to pull the chair so that Ruth Garrett would fall, and Q represents Brian Daly caused Ruth Garrett harm, answer the following questions. Now remember, in order for a battery to exist, in order for Brian Daly to be guilty of battery, there has to be intent and harm. So let's look at problem A. If P is true, so Brian Daly didn't intend to pull out the chair so that Ruth Garrett would fall, and Q is true, Ruth Garrett did get harmed, is Brian Daly guilty of battery? Yes, this one is true. He is guilty. Notice the word that is being used here. The word is and. So this is a conjunction. In order for the conjunction P and Q to be true, both P and Q have to be true at the same time. So is P true here? Yes. Is Q true here? Yes. They're both true at the same time. This one's true. If P is true, so Brian Daly did intend to pull the chair out, but Q is false, Ruth Garrett did not get harmed, is Brian Daly guilty? No, he's not. In order for there to be battery, there has to be intent and harm. And now the conjunction would be that he's false, because you had P is false, or excuse me, P is true, Q is false. In a conjunction, you need both P and Q to be true at the same time. If P is false and Q is true, so Brian Daly did not intend to pull the chair out, but she did get harmed, is he guilty? No, he's not. There was no intent. So in this case, P is false, Q is true. Is Brian Daly guilty? No, he's not. This would be false. Remember, the conjunction says both have to be true at the same time. If P is false and Q is false, is Brian Daly guilty? No, he's not. There was no intent. There was no harm. This would be false. I believe that when I was going over it, at least in 4th period, I don't recall what I did in 1st period, but at least in 4th period, I took this initially as an implication, if P, then Q, but that's not what this is. So my reasoning, my logic behind the example was incorrect to begin with, but I corrected myself. So I just wanted to make the video to make it a little bit more clear that these are the correct answers to this conjunction. So again, when you have a conjunction, both P has to be true and Q has to be true. If either one of those or both is false, then the entire conjunction is false. So let's look at section E. If we say that Brian is guilty when there is intent and harm, we can call this P and Q. When this is true, Brian is guilty. Complete the truth table. Well, we basically already have a truth table here, so this is true and true. P and Q. So I unwittingly made the truth table already. When you have P is true, Q is true, conjunction is true. When either one or both are false, the entire conjunction is false. Good. Let's go into number 7 from section D. This was part of your homework. Somebody asked to go over this in 4th period, but we ran out of time. So complete the truth table for this here. This is the exclusive disjunction. Exclusive disjunction means only one can be true, not both of them. So it's either or. In this case, P is true, Q is true. Since they are both true, the exclusive disjunction is false. Now, in this case, P is true, but Q is false. Remember, this is exclusive disjunction. Only one can be true. In this case, only one is true. So the entire disjunction, exclusive disjunction, is true. Same thing applies here. One is true. so the whole thing's true. Here, P is false and Q is false, so the entire exclusive disjunction is false. One of them has to be true. So now let's look at the Q and the disjunction. Remember, in order for the conjunction, because that's what we have here, this is what we have an and. In order for the conjunction to be true, both of these have to be true at the same time. Now we're looking at Q and P. One is false, one is true, so this thing is false here. False. One is false, one is true. They're not both true at the same time. This is false. They are both true here at the same time. This conjunction is true there. And they're both false here, so this would be false. Okay, good enough. Now we're looking at the disjunction of the exclusive disjunction and P. Remember, in order for it to be true, a traditional disjunction, either one or both of these propositions has to be true. In this case now we're looking at, oops, excuse me, we're not looking at that. We're looking at the exclusive disjunction and P. Either this one or both can be true in order for this disjunction to be true. So here we have P is true and the exclusive disjunction is false. Since one of them is true, the whole thing is true. Here we have both are true, so this whole thing is true. Here we have only one is true, so the whole thing still remains true. Here we have both are false, so this is false, because in a disjunction, in an or statement, one or both have to be true in order for the disjunction to be true. This is where we left off. Consider the proposition P is x values between -3 and 7 inclusive, and Q is x is greater than or equal to 2. Find the values of x which make the following propositions true. So for part B1, let's just write out all the values of x. So P, we have -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. That's P. Now let's look at Q. We have 2, 3, 4, 5, 6, 7, 8, all the way to infinity. So now the exclusive disjunction is when only one of them is true. So let's look at this here. When we start at P, we're going to go from -3 all the way to 7. And Q starts at 2 going all the way to infinity. What numbers do they share in common? 2 through 7. 2 through 7. So now the x values that make it so that only one is true, not both, is from -3 all the way to, so this is greater than x 1. You see, these x values are only true here. Also, these x values, anything greater than 8, is only true in Q. So the exclusive disjunction is only when only one of them is true. So between -3 and 1, those values are only in P, not in Q. From 8 and on, those values are only in Q, not in both. So we have our exclusive disjunction here. These values are what make the exclusive disjunction true. Now, when do we have Q and the exclusive disjunction of P and Q? So what values are in Q and at the same time are in the exclusive disjunction, which we already identified as being these? Which values are in both? Well, all values that are greater than or equal to 8. All these values, we already identified them as being part of this exclusive disjunction. All of these values are also part of Q. They both have to be true at the same time. So these values are the answer for part 2. Now we have the exclusive disjunction, which we already identified here, or P. So we want the exclusive disjunction with a disjunction of P. So what values make this true? Here, are they in these values, or here? Well, we have between -3 and 1. Anything greater than 8, that would make the exclusive disjunction true. Now all values between -3 and 1 make P true. So these are all the values. Basically, these are duplicates of this. So these are all the values that would make this disjunction of the exclusive disjunction of P and Q, or Q, be true. Briefly, let's go into number 9. What can be said about the negation of a logical contradiction? Remember, in a logical contradiction, all of the values in the truth table are false. All of them. That's what makes it a logical contradiction. All of the values in the truth table are false. So if we're going to negate the logical contradiction, the negation of logical contradiction are always true. And what's it called when all of the values in the truth table column are true? That's called a tautology. So the negation of a logical contradiction is the same thing as a tautology. So what's the negation of a tautology? Remember, a tautology is when all the values are true. So the negation of a tautology would be all false. And when all the values in the truth table column values are false, then we have a logical contradiction. So the negation of a tautology is a logical contradiction. So they're kind of opposites of each other, they're negations of each other. So now we're asked about the disjunction of a tautology and any other statement. So we want the tautology or any other statement. So we're going to say X, whatever X is. Well, since we know the tautology would always be true, it doesn't matter what X is, whether it's true or false. The disjunction says either one or both have to be true. Even if this other statement is a logical contradiction, since the tautology is included in there, either one or both have to be correct. The tautology ensures that one is always correct. So the disjunction of a tautology in any other statement is a tautology itself. It's always true.